Hello, Assalamualaikum everyone. I'm Ayman Tanvir Hussain from Department of Tripoli, where today we will be going through some of the fundamental topics of CSE 460 VLSI design. So the MOSFET or the MOS transistor is one of the primary components of modern IC. The MOSFET actually represents the metal oxide semiconductor field effect transistor. We can see the symbolic representation of two types of MOSFETs, the NMOS or the N-type MOSFET and the PMOS or the P-type MOSFET. Here we can see that the MOSFET has actually four terminals, the drain terminal, the source terminal, the gate terminal and the body terminal. The gate terminal actually represents the metal. The oxide is actually the insulating layer between the gate and the semiconductor, and the semiconducting part is actually the drain terminal, source terminal and the body terminal. Here the field effect actually represents the voltage control part of the MOSFET. In MOSFET we actually control the current between the drain and the source by the voltage at the gate. So the MOSFET is a voltage control device, and the gate voltage actually controls the current between the drain and the source. Here in the PMOS, there is actually a negation sign or a small circle. This is because the NMOS turns on at a higher voltage, like 5 volt, whereas the PMOS turns on at a lower voltage, like 0 volt. After that, we can see the cross section of the NMOS and the PMOS transistors. Here, the body of the NMOS is of P-type, and the drain and the source terminal are heavily doped N-type regions. Here we can see that the gate terminal is made of polysilicon and there is insulating oxide in both NMOS and PMOS. In the PMOS, the body is made of N-type semiconductor and the drain and the source terminal are heavily doped P-type semiconductor. Previously we said the metal was the gate, but actually in modern MOSFETs, the polysilicon gate is used because it is easier to fabricate and it can be easily doped. So the drain and the source terminal are identical at the MOSFET. So how can we determine which is the drain terminal and which is the source terminal? Actually, it is determined by the voltage. In MOS, the source terminal is always at lower potential, whereas in PMOS, it is always at higher potential. So typically the body of the PMOS and the NMOS is connected to VDD for PMOS and ground for NMOS for operation. We can see the advantages of the MOSFET. It is a unipolar device. So why it is a unipolar device? Because whenever the gate gets a positive voltage, it actually attracts electrons in from the body between the drain and the source terminal. So an inversion channel is formed because it was actually a p-type body and the n-type channel is formed there. So here it is also the majority carrier, and the majority carrier actually forms the channel, conducting channel for the device to operate. So we can say that it is a unipolar device because only one type of carrier is actually operating, and it is also the majority carrier device. And whenever the gate voltage of the MOSFET is below the threshold voltage. The MOSFET doesn't turn on, the inversion channel doesn't create, so the MOSFET current is actually zero. There is no current between the drain and the source. And whenever the gate voltage is actually greater than the threshold voltage, IDS flows and IDS is not equals to zero. So the MOSFET can be turned on and off easily, because as the MOSFET is turned off, there is no current flow, so the power consumption is less. So in the NMOS, if we want to flow current IDS, then VGS must be greater than VT. So from that we can write VG minus VS is greater than VT, and VS actually comes which is less than VG minus VT. For the NMOS to turn on, VG is actually 5 volt or should be at higher potential. And for typical MOSFETs like PMOS and NMOS, the threshold voltage is between in the range of 0.5 volt to 0.7 volt. So we can see that the source voltage actually comes 4.5 less than 4.5 volt here. So we can say that the source voltage can be as high as 4.5 volt, but it can actually go to low voltage as 0 volt. So it can never be high from 4.5 volt like 5 volt. For the NMOS, it is never possible to achieve 5 volt because it will break the condition set. So from that we can say that the NMOS passes good 0 and bad 1, and for the PMOS similarly we get this condition: Vs is actually greater than Vg plus Vt, and Vg here in this case to turn on the PMOS is actually 0 volt, so Vs must be greater than 0.5 volt. So the source voltage of the PMOS can be as low as 0.5 volt, and it can go up to 5 volt and beyond. So Vs can achieve 5 volt here, but it can never go below 0.5 volt, so Vs cannot be equals to 0 volt. So from this we can say that the PMOS pass is good 1 but bad 0. In the CMOS structure, the CMOS is actually complementary MOSFET. So we actually use a PMOS and the NMOS. And the simplest structure is the CMOS inverter. In a CMOS inverter, we assume the output has a capacitor CY. Here, the gate of the two MOSes, the PMOS and NMOS, are connected to the A terminal, and the source of the PMOS is connected to higher potential 5 volt, and the source of the NMOS is connected to the lower potential 0 volt, and both of the drain of the two MOSFETs are connected together to the output at the Y terminal. This is the CMOS inverter structure, and whenever we put VA is equals to 0 volt or logical 0, the PMOS will turn on and it will pass the good one to the Y terminal, and CY will get charged to 5 volt and we will get output 1 at the Y terminal. And in this case, the NMOS will be off because a VA is equals to 0 volt. We know that for the NMOS to turn on, we need a higher potential. And when the VA is 5 volt, in this time the NMOS will turn on and the PMOS will turn off. So the capacitor will be discharged through this path to the ground, and in the output we will get 0 volt. Finally, we look at the truth table of the inverter. So in inverter, whenever we put a logical 0 at the input, we get a logical 1 at the output, or logic high at the output, and whenever we put logic high at the input, we get a logical low at the output. And this CMOS inverter actually follows this property. We have seen that. And the CMOS inverter is actually very power efficient because in both the cases of operation, actually one of the MOSFET is always on and the other one is off. So there is no connection between the VDD and the ground in any case of the operation. So there is no static power consumption and it is very power efficient circuit, and it is highly used in modern ICs. So this was my lecture. Thank you.